Hey, hi all. Welcome to Networkers Champ again, YouTube channel. So today we're going to discuss, the OSPF. Uh, Previously, we have already discussed theory. Like when we say theory, we have discussed about the OSPF features. We've discussed about the OSPF packet types and OSPF neighbor states, right? And same thing we are going to implement in the lab today. So the today's agenda is going to be configuring OSPF basic lab. So we'll see the neighborship by the way, how it goes through the different states, right? And how the different OSPF packets are being used, right? And then we'll also talk about the OSPF network type, right? So we'll discuss and configure the different OSPF network types like broadcast, point to point, and non-broadcast in BMA. While talking about the broadcast, we'll also, you know, look into DR and BDR concept, and we would see why, how to configure DR and BDR on the broadcast network. So let's get started. We have already covered this part, right? The commonly OSPF, terminology is used. We have discussed. Just follow my previous video to have more idea about it. We've discussed about these terminologies again and then again. Anyways, we are going to discuss again and again, so don't worry about it. We have also discussed all these points mentioned, right? Um, and then followed by these other points as well, right? So uh, previously we discussed as in how OSPF forms the neighborship, right? And this is where we discussed about the hello packet. These are the information a hello packet contains, right? And out of which the anything with the star, it should these parameters should match to form the neighborship, right? So and then we also discussed though about the OSPF network types, right? And this is the time to implement it. And then uh, certain OSPF LSA types also we discussed, right? Which we'll again discuss maybe today or if time allows, otherwise we'll discuss it tomorrow. Now, OSPF message types, right? We have covered theory as well as the OSPF neighbor states. Now, today, as I mentioned, we are going to demonstrate in the lab and, you know, enabling some debug commands and see how we can see in the real environment, right? um, these states, right? And for that, let me bring up my topology. So this is the topology. Okay. The IP schema is pretty much straightforward. This basically is between R3 and R4. So I have configured 3434 here. And then I have loopback 333 and 444 here, right? And this I'm going to configure in area 0 as in backbone, right? So first thing what I'm going to do, I'm going to, because it may have some existing configuration, right? So OSPF configuration. So I'm simply going to say no IP routing and IP routing to enable to disable and enable again. Same thing goes here. I would say no IP routing. And the only reason I am saying this no IP routing to remove OSPF any routing from this and enabling it again. So basically any routing protocol that I have configured on these two routers would be wiped out after disabling the IP routing, and then I would enable again. I have found it actually the smartest way actually is to remove the configuration rather actually going ahead and configure removing OSPF, removing ERIP, OSPF, removing BGP, and etc. Okay, cool. So as simple as that, what we're going to discuss here is how these OSPF packet types are used, right? And then followed by the OSPF neighbor states. And also we'll talk about some artifacts like how the OSPF selects the router ID. I hope you guys are aware of, we have already discussed, but let's quickly cover here. So what I would do, I would get into router OSPF 100, right? As soon as I do this, you would notice one thing that you know, this router has taken one IP as a router ID automatically. Now, how router ID is selected? I'm not going to spend so much on that, but let me tell you. The router ID is selected based on the whatever IP that you configure manually. Okay, what manually as in what is the command to configure manually? Say router ID and 3.3.3.3.3, whatever IP. Okay, that's the first step. If you don't configure it manually, then it will take the highest loopback IP of the router. So in this picture, you see there is a loopback interface, there is loopback IP configured, there is loopback interface with the IP 333, and that is why this router has taken as a router ID, right? Let's say if you don't have loopback, then it will compare, it will see out of the physical interfaces, right, which IP is the highest. So in this case, if no loopback, then we have S11 and S1/0, right? It will see which one is the highest. And I see 34.34.34.1, is higher than 23.23.23.2 or anything, right? So it will take this IP as a router ID, right? So that is how actually it selects the router ID. Cool. But if you want to change the router ID, right, and anytime if you want to change, let's say you configured serial and interface IP, physical interface IP, and it took the physical interface IP. Later you want to change the router ID, right? What is the process to change the router ID? Let me tell you here. So again, router ID and select, let's say, 34.34.34.1. Okay, and then do again show IP OSPF. You see it would take the router ID immediately. Okay, one thing I would again mention, but let me again go take it back to 3.3.3.3. Cool. Now what I'm going to do, I'm going to configure here also. So let's say router OSPF and 100 process ID I have used here 100, right? It will take 4.4.4 as a router ID. Now, um, as of now, it won't send any hello packet, right? Why? Because we haven't advertised any network. So what is the next thing? Let's advertise the network. And as soon as you would notice, as soon as we advertise the network, it will start sending the hello. For that, I would enable two debug commands: do debug IPOSPF adjacency and do debug IPOSPF events. Okay, so you see, and also I would enable, let's say, packets to debug IPOSPF packets. Okay, so let's advertise 34.34.34.0 and with 255 area 0. But I want to check what IP it is. Is it 32 or let me see. I would quickly say do show run interface CL1/0 and the IP it is. Okay. So yeah, network 0 with wildcard mask and then area 0. As soon as I do, you will notice one thing. It will build the LSA, right? And then it will build the LSA, right? And then, okay, so there are some configuration. But you see here, immediately it is sending the hello now. It is sending the hello to multicast address from its own physical interface IP. Right? You can share this student. It basically keeps on sending hello in every 10 seconds. That is the first OSPF message type that we have seen here. This one, isn't it? Then what next? As of now, nothing is happening and the neighborship will still be down. To show IP OSPF neighbor, as you see, it is down. Let me advertise here also. And as soon as before advertising, do debug IP OSPF adjacency, and events, and packet packets, right? So let's advertise network 34 or 34 or 34.0 with wildcard mask with area 0. And as soon as do that, you would notice one thing, lot of messages. Do and debug all. Okay. So let me remove this, do and debug all to disable all the debugging. Now we have got some information. Here it says we have received the hello from 444 on this interface, right? And this is where this state is in it. You see, state is in it. And also they receive the database description, which is the second, right? Database description over here, DBD, right? This is the second OSPF packet types. So receive the database description on this interface and two-way communication and state is two-way here. I'm talking about this OSPF, two-way state, right? The two-way state means all parameters that we have discussed over here, where over here are matching, right? This is optional, by the way. We are not using it, right? And rest everything it is matching. All the packets, all the parameters, and that is why you see here. Also, it is trying to, uh, you know, so after this two-way, they would now exchange the, database, and based on that, they would select master or slave, right? So one router will be selecting as a master, selected as a master. The other router will be selected as a slave. The highest IP address will be master, right? So that's basically the next state, OSPF state here, right? Xstart. So currently negotiating the DD sequence and selecting master and slave logic here, right? And then finally, next state is exchange. This is where they finish negotiating DD process particularly and currently exchanging DD packets. And you would see here exchanging, receive DVD, send DVD, and then state is exchange, right? State is exchange, exchange done, isn't it? State is exchange. Now, in the next state, which is loading, they will send link state request, link state update and acknowledgement. Other OSPF packet types over here, LSR, LSU, and LSAC, right? So you would see here, uh, send LSR, link state request packet to this. As of now, you would not see update and acknowledgement because there is no update here. But then you would see also synchronized with this state is full. State is going from loading to loading done, means loading to full. So that is another state of OSPF, right? So that's what we did actually quickly here, this part. Oops. Neighborship. Next is basically configure OSPF network type. So let's understand as of now, OSPF network type here. By default, when you configure this interface, advertise, right? By default, it takes do show IP OSPF interface CL1/0. By default, it is a point-to-point. And as we have discussed, in point-to-point, we P2P, we don't have DR-BDR first, right? And timers and all our automatic neighbor discovery happens. Yes, they should be in the same subnet. Yes, right? No DR and BDR. And you can see here, the network type it is point-to-point. And that is where it is selected. Now, next thing what we would do, we would use the broadcast, right? So to change the broadcast network type, interface serial1/0, go under the interface and say IPOSPF network type, let's say broadcast. As soon as I do, they would break the neighborship because the network type one side it is point to point, the other side it is you know, broadcast. So I have to change it here also. Serial 1 slash 0. It is serial 1 slash 0. Yes. And say IP-USPF network type broadcast. Now, what happens in broadcast, by the way, guys? In broadcast network type, you see, first of all, the DR-BDR is selected. Now, we all are aware of, right, how where in which scenario broadcast is selected. It is on the Ethernet environment, isn't it? And it uses basically what LSA? LSA 2. Timers 10 second again. Discovery, yes. Subnet, yes. But the new thing here is DR and BDR is selected, right? So if I go here and say do show IP-OSPF neighbor, and you see here do show IP-OSPF neighbor, right? R3 is saying R4, 4.4.4 is the DR for me. This neighbor is DR for me. Why? We know why, right? We know we've discussed what is the DR selection process, right? The DR basically it is highest, the priority by default. The priority is 1 1 here, right? 1 and 3 R3 R4 1. So it goes with the highest router ID. Highest router ID R4 has the highest router ID. Hence R4 becomes DR, R3 becomes BDR. In this case, because there are only two routers, right, on this particular area, right? But if you have, let's say, other routers also, they would become DR others, right? But what if I want to change? Let's say I don't want R4 to be the DR, but I want R3 to be DR, right? How you can do that? You can achieve this by changing the priority. As of now, priority, see, 1. By default, it is priority is 1 on the selected, right? I can change it. How would you change it? So IP, OSPF, and say priority. R3, I want, to be DR. So I would say 254, let's say. Okay. And here IP, OSPF priority 253. So that this router should become BDR anyways. Now, one thing you would notice, even after changing the priority, they will still be on the, DR and BDR. They would not leave the role. Why? Because there is nothing like preemption here, right? On the in the DR selection process. At which basically state the DR BDR selection happens at two-way state, right? Now, the two-way already done. Two-way is already done. Okay, because they have already established a neighborship. Somewhere, somehow, you need to, you know, ask your neighbor to, hey, select the DRBDR again. And for that, you need to clear IP-OSPF process. Say yes. When you clear, this router would go, through the entire, again, whole state, OSPF state, including DRBDR. And this is where it selects new thing, says, hey, I have found 333 with the higher priority, which is 254, and let me select as him as a DR. So R4 now considered R3 as a DR here. And you see R4 is the BDR, right? So that is how we change this into the network type to basically broadcast, right? Point to point we discussed, and then we also, tweak with the DR and BDR on the configuration part. Next
Yes,
thing is,
hello,
yes,
hello.
go ahead.
Um, I just want to know something there. In which case we can use the type of broadcast? In which case?
On the Ethernet environment, I think yesterday also I mentioned, right? So on the Ethernet switching environment where you have many, routers connected on the Ethernet environment, that type that that is a scenario where we can use actually the broadcast.
Oh,
So
okay,
let's say
okay.
we have multiple routers on this, right? And these routers are connected to the switch like that. So this becomes itself is a broadcast environment because the prefix that IP what you would configure here, they would be in the same broadcast domain, right?
Mm.
So there it will be selected as a broadcast. But then you can change it. Does does this give you answer?
Yes, understand. You understand.
All right.
Okay.
The next thing we will discuss here, non-broadcast NBMA. But let's
Mm.
understand this NBMA scenario first. Okay, what is the NBMA
Mm.
scenario? The NBMA scenario is non-broadcast multi-access. Non-broadcast means it is not broadcast, but multi-access. It has multi-access. Think of let's say think of this environment. We have some hub and spoke topology. Okay, and here we have some environment called, let's say, some frame relay environment or ATM enrollment environment, right? On those kind of scenarios, if you guys have little bit idea about frame relay or ATM, which we don't use nowadays, by the way, right? But what exactly this device is connected to frame relay, and this is connected to another let's say branches, right? Now what happens? It is non-broadcast because what IP you would configure here, it would be different from this IP, and it would be different from this IP and this IP. So ultimately, it would not make a broadcast. But because in frame relay we use something called DLCI, so simply similar to MAC address. Okay, so we do this DLCI is layer 2. Okay, so we do layer 2 to layer 3 mapping. How we do layer 2 MAC to IPI mapping, right, in the Ethernet environment. In case of frame relay, I just, to be honest, I don't want to get into in too detail, right, because we don't use frame relay and all nowadays. But then this DLCI mapping makes this as a multi-access. So even they can, they are not in the same network, right? But they can still reach using the DLCI if the DLCI mapping is correctly done. Okay. So those kind of scenario you can configure non-broadcast NBMA. But NBMA, when we say, as you see here on the point to point, whenever you use NBMA, the DR-BDR selection will happen here. Yes. But see the timers here. Notice the timer. It is 30 seconds. Means hello is sent in every 30 second. Hello is sent in every 30 second. Okay. So, and the other thing you would notice here, the discovery, neighbor discovery doesn't happen here. Subnet, yes, they should be, but neighbor discovery doesn't happen. So that ultimately means if I go back to our topology, and if I want to make this as a non-broadcast NBMA, you know, so what you would notice one thing, let's say IP OSPF network type non-broadcast. As soon as I change IP OSPF network type non-broadcast and do show IP OSPF interface CL1/0, it says it is network type as a non-broadcast. Okay. It says do show IP OSPF interface CL1/0. It says network type is non-broadcast. But you would notice here the neighborship would not come up. Why? Because in NBMA, there is no broadcast, there is no multicast traffic, right, allowed. In a non-broadcast multi-access, there is no multicast traffic allowed. So anyways, OSPF uses basically the multicast to send the OSPF hello packet, right? But since it is NBMA, there would not be any hello packet processed by default. Then what? Solution is we need to configure the neighbor manually. Okay. How? So I would go into router OSPF 100 and say neighbor. Neighbor is 34.34.2. This is my neighbor. And along with that, if you want to select some costs, and all that, you can do that. As soon as I do that, okay, you would notice here do debug IP OSPF packet. It will start sending packet, but that packet again would be the unicast packet because I am giving it here, as a uh, individually adjacency and events. But also, hello is sent in every 30 seconds. Just remember, not in 10 seconds, right? The timer here is 30 seconds. You see, send hello on area 0. Electric DR, BDR, all that happens, right? But attempt. See, this attempt state you will only see in NBMA case, right? It is not actually forming the neighborship. Why? Because you need to configure here also. So I would say neighbor 34.34.34.1. And as soon as I do, this router would also send the hello, right? Rest all parameters would be matched here. And then finally, they would form the neighborship as soon as the OSPF packets are being exchanged, right? But the timer here is 30 second and the whole timer 30 multiplied by 4, 120 second. 120 second. Okay. So, oops, neighbor 34.34.1. I think yes. This show IP interface brief. I'm just okay. Here is a mistake. The neighbor is not actually this, but the neighbor is 3. Here also. See, I mean, you don't have to actually configure, by the way, everywhere. Even if you configure one router, the neighbor, they will form the neighborship. And you see here the attempt down and neighborship should be do show IP OSPF neighbor. It's in init state. And let me just configure, by the way, here neighbor also 34 or 34 or 34.4. And here we go. Adjacency done. So this is manual. That is how we configure the neighborship manually. Right? Any question from NBMA?
No, no.
Cool. Right. So that's basically with that we are, achieving the our we are covering all the topics that I have mentioned in this agenda. But let me quickly see if I can cover something else. When I say something else, LSA types, by the way, we have already discussed. So all good. Let me see from the anything from PPT. Let's say OSPF message types. Hello. Okay. The authentication. Yep. Let's cover on on the same OSPF authentication as well. So first, I would add here OSPF authentication. Okay. So in OSPF authentication, we'll talk about type 1, type 2, and type. Do we have type? Null, right? So these are the authentication. As you see here, type 0, type 1, type 2 actually. So there are three types of authentication that OSPF supports. Type 0 means no authentication. So if no authentication, then it would not basically take, I mean, it is called as a type 0, type 1 as in plain text, type 2 as in MD5. Now just remember, the authentication, if you are using, the authentication should be same on both the routers, then only they will form the neighborship. Otherwise, they will not form the neighborship as we discussed in hello packet, right? So type 1, anyways, it is plain text. So the password between two routers would be exchanging, in clear text, and any hacker can see what password you're negotiating. MD5 is, encrypted format. So the password would be encrypted, even though the hacker, captures the password, won't be able to decrypt it, which is the most secure, right? Now, whenever you configure the authentication between two neighbors, authentication must be enabled. So there are two pieces of it, right? One, to enable authentication, as in what you want to enable, whether type 1 or type 2 you want to enable, right? Plus the authentication type must be selected through one of the two means, right? So what it says is enable the authentication, right? To enable the authentication, you can enable the authentication for interfaces using the IP-OSPF authentication command, or you can also enable the authentication on area wise. So if you are enabling under the area, all interfaces, authentication will be enabled on all the interfaces, right? And then the second part of it is configure the authentication. So in order to configure the authentication, right, you need to specify the whether it is, let's say it is, if I IP-OSPF authentication, right, and then give the key IP-OSPF authentication key and then key value, right? This is type 1. If you are configuring type 2, then IP-OSPF authentication message digest, IP-OSPF message digest and key, and then you would use the key value here. If it is null, IP-OSPF authentication null means type 0, means no nothing, right? So in our example here, R3 and R4, right, they are already configured with the authentication. Let me quickly see what it is. So if I go and say do show run interface CL1/0, you see there is already authentication configured here. Okay. So this is the command IP-OSPF authentication message digest to enable the MD5 authentication. And this is the command, IP-OSPF message digest key 1 and then MD5 and then champ. What is champ here? So do show run section keychain. I have created here the keychain. The name of that keychain is champ. Okay. So in order to configure authentication type 2, what do you need? The first thing what you need is you need to configure the keychain. Inside of that keychain, you would assign the key number, which is key 1. That is where I have given here, you see. Just do undebug all. Here I have given key 1, right? And the name of keychain. And then key string Cisco. This is the password that they would negotiate inside. Okay. Same Same details I have also mentioned here on the other router. So this also is same. Keychain, Champ, Key1, and Cisco. Obviously, this is the password, right? So it should be same on both the router. Once you configure the keychain, what you need to do is go under the interface serial1/0 and say IPOSPF authentication, and you see here message digest and enter. This is the command to enable the authentication. Let's say I don't have interface CL1/0 and I say no IPOSPF authentication message uh, anything, right? Uh, so let me see if that has been removed. Uh, and then I would say this also. See, so on this router, I have removed the authentication completely, but on this router, I still have that message digest. Okay. Now, enabling OSPF doesn't actually break the neighborship unless and until you configure the password, isn't it? Unless and until you configure the password. Do you think this statement is true? I would say no. If you see here,
Yes, no.
the dead time, right, it is reducing. And as soon as the whole dead time, which is 120 seconds, okay, 4 times of, right, it will break the neighborship. So just to take immediate effect, what I would do, IPOSPF network type, I would simply say, let's say point to point, just to, IPOSPF network type point to point. Now you would see, because there is authentication mismatch here, right? You would not see the OSPF neighborship coming up. Why? Because here you have um, to show run interface L1/0. Here you have authentication enabled and configured with keychamp. Here you don't have any authentication, right? And that is why it proves if the authentication is mismatch, neighborship will not form. So I would say here the authentication message types and then IPOSPF message digest key 1 mode, which is MD5, and the name of keychain that we have created, which is Champ. As soon as I do that, right, you would see the neighborship coming up. Here we go, right? So that is how we configure the MD5. Now, if you don't want to configure the MD5, let's say I would remove this and, you know, I would remove it from here also. Now, on one router, I would say IPOSPF and simply say authentication and enter. IPOSPF authentication itself means what I have enabled is I have enabled the plain text authentication type 1. And now if I do this, it is still the hold down time, it is 40 seconds, right? It is getting reducing 11, 7, 6. Soon enough, you should see, here we go, down. State is down. In interview, they ask this question actually, when do you see the state down? And here is the answer. When you have authentication mismatch, right? It will straight away go to the down. It will straight away go to the down state, right? Now, if I go ahead and say IP-OSPF authentication here also, immediately this basically would come up. As soon as the hello is exchanged, because the authentication matches now, plain text though, we haven't configured password, that is also correct, but authentication is matching, they would come. If I configure here the authentication, let's say authentication and say key Cisco, right? Again, the neighborship will go down after 40 seconds, right? So we can quickly verify 24, 17, next 9 and 0. And you would see if I do, if I enable debug, let's say IPOSPF, adjacency and events, okay, you would see the message here. What message? OSPF received packet from 34 mismatch authentication, and it would also say clear text. Means we both are using the type 1, but clear text is the mismatch, right? If I remove this, let's say, or if I configure it here also, IPOSPF authentication, key, Cisco, immediately the neighborship would come up. Okay, so that is how basically we configure the authentication, and this is the concept behind it. Any question from this authentication?
Authentication for me is clear. Type 1